that biology is a career subject, and we have seen careers where it is applicable. Biology is important in solving of environmental problems. It gives scientific skills to the learner, such as observation, classification, analysis, and so on.
Welcome to our today's history and government lesson. Your teacher, Conan Gakure. It's my pleasure to have you in today's lesson. We are going to introduce a new topic, that is the establishment of colonial rule in Kenya. That is the next topic of Form 3 that we are going to be discussing. In this unit, we are going to dwell more into the Kenyan, the establishment of colonial rule in Kenya. In the previous topic that you have studied, we were learning about the European invasion and the process of colonization of Africa. We discussed how the European powers scrambled, were fighting, were competing against each other, right? That is the scramble, the sudden rush. So the European powers rushed into getting colonies or territories in the African continent. That is what we defined as the scramble for Africa. And then after the scramble, they sat down during the Berlin Conference, if you can remember, that was held in which year? I'll give you that. You should be able to know the year in which the Berlin Conference was held, that was led by Otto von Bismarck, the Chancellor of the German Republic then. So they came down and sat and decided to subdivide, partition, share in an organized manner. That is partition. So they partitioned Africa amongst themselves. That is the partitioning of Africa. So Africa was now subdivided as a continent. It was subdivided. Each European power took part of the continent for themselves. The European powers that were struggling or that shared the African continent, that they refer to as the African cake, right? Can you remember which are these powers? Can you mention them? The powers that subdivided or took territories in Africa, the European powers. Which are they? British, very good. We have the French, very good. We have which other? We have the Italians, we have the Germans, we have the Belgians, right? These are some of the powers. We had Portugal, some of the European powers that came to get colonies. Are you able to remember the reasons that we gave? Why were they so much interested in getting these colonies and getting each and every person getting a portion of the African continent? There were so many reasons that we gave. We divided them into social, into economic, political, human, and then the strategic reasons for them scrambling and partitioning Africa. And we are not going to dwell in that because we have already tackled that. So based on that, now we come down into and look at now how the Kenyan territory was colonized. And the first thing to mention, it was colonized by the British. The British took control of the Kenyan colony. But before that, I would want to give you a background of how they ended up coming to take position of Africa. So, of Kenya, sorry. Kenya is part of the East Africa. Kenya is part of East Africa. In East Africa, we have other nations at that time. We have Tanzania, we have Uganda, we have Ethiopia, right? The eastern part of Africa. So there were different powers that were interested in getting the East African territory. Some of these countries are Germans. Germany was one of them. We had Britain. We had Italy. Right? We had Italy that were competing to get the East African territory. We also had the Portuguese, who had come earlier than these powers. Remember in your Form 1 work, the contacts between East Africa and the outside world. So East Africa had been exposed to the outside world through trade. That was the main thing that exposed the East African coast to this power. So by the trade, it attracted these powers to come and get colonies in East Africa because of the trade. People were able to know that East Africa is rich, and now these powers came and competed to get a portion of the East African part of the African continent. So these are the countries that were fighting. So they had, after the Berlin Conference, they had to divide the East African continent amongst themselves. They made a protectorate, and I'm sure you discussed that. You know what a protectorate is: a sphere of influence where power has been put in place. So Britain took control of Kenya, which is the land where we are living in. The boundaries of Kenya, we were colonized by Britain. So you ask yourself, what are the factors or what are the reasons why the British were so much interested in taking Kenya as their colony in East Africa? Because remember, they were competing with all these other nations. So there must be a significant reason or reasons why these powers are fighting or struggling to get each other, or struggling against each other to get part of the colony of Africa. So that is what we are going to be discussing. Let us start with that at that point so that we are able to go forward. So the factors, you can also refer to that as reasons for factors for colonization. Factors for colonization of colonization stroke occupation. Stroke occupation of Kenya. Remember, we are saying, and I've mentioned that it was occupied by Britain. So what are these factors that encouraged or made it necessary for the British to come and occupy Kenya? The first one was the source of the Nile. The source of the Nile. Remember, the Nile starts in Uganda, right? And we said it was very essential because Britain had occupied Egypt. So it was necessary for them to secure where the Nile starts because Egypt is a desert. They do not have their own sources of water. They heavily relied on the Nile as a source of water. It provided, the Nile provided water. It also provided silt. Silt that could be deposited on the shores of the Nile towards as it goes to drain into the Mediterranean Sea. So it carries along the top soil from the highlands, from the East African highlands, the Ethiopian highlands. So it was very essential for the British to occupy Kenya and Uganda being one, at that time the British protectorate, so that they are able to protect the source of river Nile. Why? Because they had occupied Egypt, and as we discussed in our previous topic, Egypt was very strategic, or was very important to them because of the Suez Canal. So it was necessary for the British to come and occupy Kenya so that they could safeguard those interests, the source of river Nile. That is the first reason why they were very interested in occupying Kenya. Number two, they had strategic, Kenya had strategic interests, or the strategic position of Kenya on the coast, on the East African coast. So British had interest in India, right? They had interest in India. They had colonized India, and it was very rich for them. It was very essential. So Kenya was a strategic stopover position. It was a calling place for the British as they moved towards India. So they had to colonize Kenya so that they can safeguard their interest in India. They could easily move from Kenya to India in case there was need. So Kenya was of strategic importance to them. Remember, Kenya had very good natural harbors. So the British would come, dock at the coast, and take time as they move towards the Indian place. And then number three, they were searching for raw materials. They were searching for raw materials. Remember, it was during the time of industrialization. There were a lot of industries that had developed in Britain. Britain had become a superior power. Actually, it was the first country to power to industrialize. Remember in your topic in development of industry, Britain was the first to industrialize. So it had a lot of industries that required a lot of raw materials. Examples is what we have: cotton, there is tea, right? They could come and get these plantations and get these minerals and then export them or take them to Britain for the industries to produce. And then after they had processed the raw materials that have come from Kenya, they had also to look for market. So Kenya also provided a ready market. That was another reason or factor for the colonization or occupation of Kenya. So the British came because Kenyans provided a ready market for the goods. Kenyans, we were producing these raw materials, but we did not have our own industries to produce the clothing, to produce the shoes. So the British occupied Kenya in the interest that they could be able to get market for their products in exchange of the raw materials that they were producing, and also Kenyans were also willing to make payments for those goods. Let us look also at the other reasons why the British had to occupy Kenya. Number 5. They wanted to protect missionaries. So during the 19th century, there were Christian missionaries who came to evangelize. They came to spread the gospel, right? They came to spread the gospel. So these missionaries requested their mother countries or their home governments for protection. So they require to be protected. So they came and asked the home governments to provide them with support or to provide them with protection. Apart from the missionaries, there were also other people who had come to invest in Kenya. So they also required protection. Apart from protection, number 6, they also wanted to abolish slave trade. So the British came with the interest of abolishing slave trade that was happening at the coast, led by the Portuguese initially, and then we also had the Arabs. Remember, Said had established a plantation at the coast, which required a lot of manpower. So there was development of slave trade. So the British came in the interest of abolishing slave trade and in its part establish legitimate trade. So they wanted to promote legitimate trade. That is, the market, they wanted to find a place where they could sell their own, they could sell their own products. So apart from that also, number 7, they had another reason for coming to the east or to Kenya. They wanted to invest the surplus capital. So from the industries that they had developed in their homes, they had a lot of capital. They got a lot of profits from the industries. So these profits, they needed to invest it somewhere else, because now they have industries that are providing a lot of resources to them. So there existed a class of wealthy merchants, right? There are wealthy merchants or traders, wealthy merchants who wanted to advance or get or invest the monies they had gotten in new lands. So they had to come and occupy the Kenyan territory for them to continue enjoying the profits. And then apart from that, there was need or there was prestige. It was prestigious for them to acquire the Kenyan colony. It added to their interest. It added to their self-esteem that they have a new colony. And then the second last reason why they came to or occupy, or they wanted to colonize the African or the Kenyan territory, was to settle the surplus population. To settle the surplus population with production of more food from the industries. The population in Britain had increased. So they needed a place where they could settle the British community. And Kenya was a perfect place. We have a very good climate. That is the first thing. And we have very fertile land. So these Europeans had the opinion that they could come and settle in the Kenyan highlands. That is why they went to the highlands. In the highlands, at the coast, we had very nice beaches where they could relax themselves. They could swim. Right? In Nairobi, we had very fresh water that they could be able to access every now and then. And then, lastly, the independence. The independence of the USA. The independence of the USA. USA was a colony of Britain. So when USA became independent, the British turned to Africa and specifically Kenya based on the other points that I've put forward. So they wanted to get other colonies to compensate for the loss they had gotten after the independence of the USA. So these are some of the factors that necessitated or encouraged the British to come and make an occupation of Africa. So I'm sure you are able to discuss them in detail, and as we have done, and you are able to group them into economic, social, and political reasons. And I'm sure when you are asked to mention political reasons, you are able. For example, when you are told to mention even the economic reasons, you are well able, because you just talk of ready market, you'll talk of raw materials, right? You'll talk of the investment of capital, right? So those are economic. Social, you talk of missionaries and traders. You talk of when you talk of social, there is missionaries, right? And also abolishment of slave trade. That is humanitarian aspect. Political, you talk of prestige, right? You talk of the independence of the USA, right? You talk of the strategic interests of Kenya. Those are part of the politics or dealing with ruling, right? So those are the factors. So as we have introduced our lesson, our topic, so we shall in the coming lessons look at what or how did they occupy the Kenyan territory. How did the Kenyan people react towards the coming of the British, and then how did they rule the Kenyan territory? So those are the issues we are going to be discussing in our coming lessons. So allow me now to give you, as we end our first lesson, allow me to give you a revision question. A revision question for you. Actually, let me give you two questions, revision questions. Number one, identify the European powers competing for East Africa. And then number two, discuss the factors that encourage the British occupation of Kenya. Number one, identify the European powers that competed for East Africa. And then number two, discuss the factors that encourage the British occupation of Kenya. So those are the questions that I want you to attempt. And with that, we have come to the end of our history and government lesson for today. Thank you for your participation and for watching. Until the next time, bye-bye.
Welcome to Manifested Publishers.
Welcome, learners. My name is Stephen Kariungi. I am presenting to you a topic in Form 1 Biology, and the topic is cell physiology, as indicated here. First of all, I would want us to go through the objectives of this topic. So we look at chapter objectives. The first one, we need to understand what is cell physiology. So we need to understand the meaning of cell physiology. Number 2, we should also and active transport. So be able to state the meaning So you'll be able to state the meaning of those 3 terms, the term diffusion, osmosis, and active transport. Objective number 4, you'll be able to study the factors that affect these 3 processes, the factors that affect diffusion, osmosis, and active transport. So that is objective number 4. Then we go to objective number 5. We should also be in a position by the end of the topic to describe some of the experiments that one can carry out to investigate diffusion, osmosis, and active transport. So we should be able to describe experiments to investigate the above processes. And finally, the objective number 6, we should be able to distinguish between Targa and plasmolysis. Those are 2 terms that we'll also be learning in the course of the topic, and we should be able to distinguish them. So those are the objectives that we shall be fulfilling in the study of the topic cell physiology. So from there, we'll embark on an introduction, and we want to understand what is the meaning of the word cell physiology. As the word suggests, it has something to do with the cell. And the fact that it ends with a logy, it means that it is a study. So in this case, in cell physiology, we study the cell functions. So in this case, we shall look at the various structures that are found within the cell and how they carry out their functions. So we will say that cell physiology is the study of cell functions. And of course, in a cell, we know that we have different structures. We have the cell membrane, we have the mitochondria, we have the chloroplasts, if it is a plant cell. So we need to understand how those structures function within the cell. So basically, we shall be dealing with cell physiology. Now, a very important aspect of cell physiology that we also need to look at is the structure of cell membrane. We need to look at the structure of the cell membrane, because before something gets into the cell or out of the cell, it has to go through the cell membrane. So the cell membrane is a membrane or a layer that is made up of 2 things. It's made up of something that is called a phospholipid and a protein layer. So it's made of 2 layers, made of two layers, i.e. phospholipid. I'll explain what is a phospholipid and a protein. So it's made up of those two layers. A phospholipid is a fat layer. Anything that ends with the word lipid, it means that it's either a fat or an oil layer. Then, of course, the other one is a protein layer. So what we are basically going to do, we are going to have a diagram showing the cell membrane and how it looks like. So the cell membrane looks like that. First of all, there is the first layer, assuming that this is the outside and this is the inside. So this first layer is the phospholipid. Is the phospholipid layer. And then the one that is marked using a different color, that is red, that is the protein layer. So basically we are saying that a cell membrane is made of a phospholipid layer or a fat layer and a protein layer. Now, in between the protein layer, there is a small opening here, and that opening we call it the pore, P-O-R-E. It's a hole that allows substances to get inside the cell and also outside the cell. So that opening is meant for that. We shall look at the characteristics of the cell membrane. So this is basically the cell membrane structure, which we have said is made up of two layers. There is a phospholipid layer on either side. Then there is the protein layer in between. There is a protein layer in between. So it doesn't have to be in one position. It can be in a number of positions. But basically, there is the phospholipid layer and there is the protein layer. Then in between the protein layer, there is a pore, or there is a hole that allows materials to get in or out of the cell through the cell membrane. And then the other thing that I want us to look at are the properties of the cell membrane. We look at the properties of cell membrane. One, we say that the cell membrane is semi-permeable. The cell membrane has what is called semi-permeability. And that means that it allows only the small molecules to pass through, but not large ones. So it's only allowing the small molecules to pass through the pore. Yeah. Those, if molecules are small enough to fit the pore, they can pass through, in and out. But if the molecules are large, they cannot pass. So we say that the cell membrane is semi-permeable, or we can say it's selectively permeable. So you can also stroke that with selectively permeable. It means the same thing. Now, characteristic number 2 is that the cell membrane is sensitive to temperature and pH. It's sensitive to temperature and pH. And the reason for that is because the protein layer and the lipid layer, they are sensitive. Yeah, if the temperature is too high, then the cell membrane is affected. If the temperature is also too low, it's also affected. Same case applies to the pH. So pH is the degree of acidity or alkalinity. So it's sensitive to temperature and pH. And lastly, number 3, the cell membrane is polarized. Polarized means that it has charges. It has charges that are positive and negative. Has charges that are positive and negative. So basically, we have looked at the objectives of the entire topic. We have listed them down. Then we have gone ahead and defined what is cell physiology as the study of cell functions. We have looked at the structure of the cell membrane, and we have seen that the cell membrane is made of 2 layers. There is the phospholipid layer and there is the protein layer. And then we have also said that in the protein layer, there is a pore that allows materials to get in and out. Then we have looked at the properties, 3 properties of the cell membrane. One is its semi-permeability or selectively permeable, meaning that it is selective. It selects the small molecules to go through, but not the large ones. It's also sensitive to changes in temperature and also pH. And finally, the cell membrane is polarized. That means that it has both positive and negative charges. So our lesson for today will end there. Then we'll have an assignment based on what we have learned. So the first question, we define the term cell physiology as we have learnt it. 2, we describe the structure of cell membrane, description of that structure. And then number 3, we state 3 properties of cell membrane. So we are going to stop there for today, and we shall continue from there next time. Goodbye.
How do you do, learners? Welcome back to our lesson. Remember, the topic is still chemical families and patterns in properties. And in this lesson, I want us to discuss the uses of alkali metals. But just before that, in our previous lesson, we discussed the similarity in the metal ions and their compounds, where we say that lithium, sodium, and potassium, they are similar, or their metallic ions are similar because they have a single charge, or they have a single positive charge, which is because they form ions by losing 1 electron from their outermost energy level. Their hydroxides, their oxides, and chlorides are also similar in a way because when they are formed, that these elements with a single positive charge now leads to their formation, and therefore you should understand the valences very well, because the valences are now going to help you to write correct chemical formulas. Therefore, in this topic, I want us to get into the uses of alkali metals. And the uses of alkali metals, I want to give you around 5, and you will look for some other uses of alkali metals and their compounds. Remember, the subtopic is uses of alkali metals and their compounds. It's not just metals, but also their compounds. And one, we can say that sodium is used in manufacture of sodium cyanide, which is used in extraction of gold. Sodium is used in manufacture of sodium cyanide, which is used in extraction of gold. Sodium cyanide is used to dissolve gold from its ore. And therefore, if you have the ore of gold, remember this ore is containing other materials, and this sodium cyanide only dissolves gold, and therefore it helps you in extracting gold from its ore. Second, sodium and potassium sodium vapor is used in street lights. Sodium vapor is used in street lights because of its yellow color, so it's also used in the street lights. Third, lithium is used in manufacture of high strength lithium is used in manufacture of high strength glasses and ceramics. I believe you know what ceramics are. These are just a hard brittle material which is produced through burning of non-metallic minerals under very high pressure. Not pressure, but high temperatures. So lithium is used in manufacture of high strength glasses and ceramics. Next, we have sodium chloride is used as additive in food. Sodium chloride is used as additive in food. It improves the taste of food. It is difficult to take food without salt because you find sometimes it doesn't have taste, and therefore you add sodium chloride that food to make it a little bit tasty. Fifth, lithium chloride is used in manufacture of dry cells, used in mobile phones, watches, and laptops. Lithium chloride is used in manufacture of dry cells used in mobile phones, watches, and also laptops. The next we have molten sodium and potassium are used in nuclear reactors. Molten sodium and potassium is used in nuclear reactors. Those are some of the examples of uses of alkali metals, and their compounds. There are many others, and therefore I want you to look for some at least 5 uses of alkali metals. But just before we end, we want to go through some of the uses. One, we say that sodium is used in manufacture of sodium cyanide, which is used in extraction of gold. Second, sodium vapor is used in street lights. Third, lithium is used in manufacture of high-strength glasses and ceramics. I believe you know the function of glasses and also ceramics. Fourth, sodium chloride is used as additive in food. It is used to improve the taste of food. Then fifth, the lithium chloride is used in manufacture of dry cells. Dry cells which are used in watches, mobile phones, and also in laptops. And lastly, molten sodium and potassium are used in nuclear reactors because of their high thermal conductivity. Therefore, that brings us to the end of our lesson. But just before we end, I will leave you with this assignment. State 5 uses of alkali metals and their compounds. State 5 uses of alkali metals and their compounds. So ensure that you've done that. If possible, look for more uses of alkali metals and their compounds. Next time we are going to discuss alkaline earth metals, which is the second chemical family we will be discussing. Let's meet then, but ensure that you've done the work, this question, before we meet next time.
How are you, dear learner? Welcome to today's lesson. My name is Wilson Mwangu. In the previous lesson, we learned about double imperatives. Double imperatives. And I said an imperative is a sentence that gives an order. For example, stand up is an order. So that's an imperative. So when you have 2 imperatives in one sentence, for example, stand up and go out, that is what we call double imperative. In today's lesson, we want to do something different, and that is writing. Okay? We want to write about an incident, about an experience, about something that happened while you were at home. And if you can remember the passage entitled Sidi and Kabetu at home, remember this passage. Sidi. Sidi and Kabetu at home. These are cousins. So while they were at home, they'd been left alone at home. They saw some people keeping items in the neighboring compound. There were electronics, very new electronics, TVs, laptops, and all that. And those people who were keeping items there were a bit worried. They were doing things in a hurry. So these 2 children got concerned. They suspected that those people were thieves. So they called the police. Okay? And when the police came, they actually confirmed that those people, actually there were 3 people, were the most wanted criminals in the town. So those criminals were arrested courtesy of Sidi and Kabetu. And in the evening, the policemen came to thank Sidi They came to see this house and thanked her for her action. So that was Sidi's experience at home. Today I want to write about your experience at home. Okay? You have been left alone at home. What's your experience? So that will be our lesson objective. By the end of the lesson, the learner should be able to write about a personal experience alone, personal experience while at home alone, while at home alone. I know once in a while you are left at home alone. Maybe during school holiday, your parent has gone out, maybe has gone to work, and maybe if you are older sibling, or maybe you are the firstborn. So once in a while, you are left at home alone. So what do you normally do when you are left at home alone? I know some of you maybe play video games, you watch TV, you also do a bit of study. But on a day, maybe there's a day when something happens, something unusual happens. So we want to write about an incident, a happening on just a single day. That there's this day when you had been left at home alone, then something happened. Something unusual happened. What was it? For example, you have your pet. Maybe you have a cat as your pet. Now this cat gets stuck somewhere, okay? Maybe it's dipped its head in a bucket or just something in a bottle, and then the head gets stuck in that bottle. Then you try to pull out. You try to rescue this cat, but becomes a bit difficult. So you are forced to call for help from somebody else. That is an incident, an example of an incident that happened. Or maybe you are at home, you are moving down the stairs, then you tripped. Then you tripped and fell and injured yourself. And you could not help yourself. So you are forced to call for help. You had to scream loudly and call for help. And then your neighbor came to help you out. Okay? That is unusual experience. So I want you to write about something that happened while you are at home alone. And of course, it must be something bad. But at the end of the day, somebody else came to help you, and all was well, okay? That's what I'm talking about. So I'm going to give you some guidelines on how you're going to write this. Just a short passage of 3 paragraphs, okay? 3 paragraphs. So let me give you some guidelines. So I told you about something unusual that happened. Maybe it even rained heavily on that day, okay? We normally have floods. So you're alone at home, then it rained so heavily that your house gets flooded with water, okay? That is unusual experience. So what did you do? Who came to help you, right? So these are the guiding questions. Paragraph 1, why were you left alone in the house? Okay, tell us why were you left alone in the house? Where had everyone else gone? So you have your parents, where had they gone? And so why were you left alone in the house? Tell us that in the first paragraph. Of course, you are going to tell us your name. Okay, tell us your name. Come and tell us your age. Tell us your name, your age, and the school that you go to, all right? And where you live, your estate, or the place where you live. Number 2, what unusual thing happened on that day? So on that day, what unusual thing happened? I've said, for example, there were floods in the house, okay? And you're forced to climb on top of the table because the whole house was full of water, okay? That's an unusual thing that happened. Or I give an example of your pet getting stuck somewhere and you're forced to ask for help, okay? Or you tripped and fell somewhere and you got injured, something like that. The unusual thing that happened on that day. So who helped you? Now here we have for example, the issue of the pet getting stuck somewhere. Your cat is stuck somewhere. Who helped you? Maybe the cat was going somewhere to hide up there in the roof. Then it got stuck, it got held up somewhere. So you could not pull it, could not free itself. So you had to call for help. So who helped you? Right? Maybe your neighbor, maybe you called your cousin, you called your big sister. Who helped you, okay? And where did they come from? Where were they? Paragraph 3, what did your parents say when they came back? So your parents have come back in the evening. What did they say? Of course, you tell them about the incident, about the happening, that your cat had gotten stuck somewhere near the roof of the house, okay? So what did they say when they came back? And how did you feel? All right? So these are some of the guidelines that you can use. So we're going to write a 3-paragraph story about an incident that happened at home. Please be creative enough, be imaginative enough. Tell us what happened, okay? And your reaction and how you are helped. All right? For example, if your neighbor helped you, what happened after that? Did your parents thank the neighbor? Okay? Something like that. So can you be creative enough and write a 3-paragraph composition, a short one of 3 paragraphs, maybe 1 page in your exercise book, okay? Yes. And once you are done, please share with us your response. But as I've said, be creative. Write about what you have gone through, okay? What you have just gone through at home, or what you have seen somebody else go through at home, right? And please share with us your composition. My dear learner, today we are going to write about personal experience. You have been left alone at home, something happens, okay? And then eventually you get helped. You get help from somebody else. So that's what we're going to write about. So my dear learner, up to that point we shall end today's lesson. Until next time, I've been your teacher, Wilson Mwangu. Thank you so much and be blessed. See you.
Welcome to Manifested Publishers.
Welcome to Manifested Online Classes. I am Teacher Purity and we are still continuing with our topic on use of medicine. So we are going to learn the precautions when handling medicine at home. Now during the last lesson we learned about the common forms of medicine that are found at home. Welcome to the lesson and hope that you will enjoy. Now, precautions when handling medicine, the things you are supposed to observe when handling medicine. Now, in our previous lesson, we discussed about the common forms of medicine that are found at home. And we say that at home you can get You can get different forms of medicine like capsules, tablets, syrups, ointment. We also have inhalers and eye, ear or nose drops. Those are the common forms of medicine that are found at home. Remember that ointment, we apply it on the skin, and we apply it on a skin where you have a bump or a swollen skin. Now I want to see the precautions when handling medicine. How do you handle medicines at home? You want to take medicine. What are you supposed to do? The first thing when you want to take your medicine, make sure that you have handled medicine with clean hands. So number 1, handle medicines with clean hands. Why are you supposed to handle medicine with clean hands? Remember, if there are tablets, you want to swallow them. And when you handle it when your hands are dirty, you'll swallow the medicine but you'll not get well because you have infected yourself with germs. You can even have more problems instead of getting well. Another precaution that you're supposed to observe when handling medicine is keeping medicine away from children. Keeping medicine away from children. Keeping medicine away from children. Children are very playful at home, and when you do not store your medicine well, they are going to get the medicine and even play with the medicine or take it instead of following the instructions. So keep all medicines away from children. Then another precaution that we observe when handling medicine is not sharing medicine. Not sharing medicine. You are not supposed to share your medicine with anyone else because all of us suffer from different sicknesses or diseases. So when you share your medicine, you are not following the doctor's instruction. Another precaution that you are supposed to take when handling medicine is using clean water when taking medicine. Use clean water when taking medicine. Use clean water when taking medicine. If you are supposed to swallow your medicine, make sure that you are using clean water. Another precaution when handling medicine, number 5, is taking the dosage as prescribed. Taking the dosage as prescribed. Taking the dosage as prescribed. When the doctor has told you to take 2 tablets in the morning and 2 tablets in the evening, don't take 2 tablets in the morning, then you fail to take in the evening. It is always good to follow the doctor's instruction because you'll get well very soon. So taking the dosage as prescribed. Learn to follow the doctor's instructions. And lastly is proper storage of medicine. Proper storage of medicine. So proper storage of medicine. Make sure that you are keeping your medicines at a safer place. Now these are some of the precautions when handling medicine. The first one, make sure that you wash your hands before you handle the medicines. Number two, keeping medicine away from children. Keep the medicines away from children because children can easily play with the medicine and some can even swallow the medicine, which is not good. Number three, not sharing medicine. Make sure that when you have been given medicine by the doctor, you are finishing the medicine. Don't give it to any other person. You are the one who is sick. And number four, use clean water when taking medicine. When you are taking your medicine, make sure that you are taking the medicine with clean water. Number five, taking the dosage as prescribed. Follow the doctor's instruction. If the doctor told you to take 3 tablets in a day, make sure you are taking 3 tablets in a day and not 2 or 4. Don't take more or less. Take what has been instructed. And lastly, proper storage of medicine. These are the precautions when handling medicine back at home. Try to practice them. When you have medicine at home, you should know that you are supposed to put it at a certain place. You know that you are not supposed to share the medicine. So I will write some questions for you on the board. Copy them in your exercise books and make sure that you also answer the questions. Now the instructions, choose the correct answer from the brackets to fill in the gaps. Number 1, we should use dash water when taking medicine. Clean, dirty. Select the correct answer and fill in the blank space. Question 2, store medicines dash from children. Away, near. You select for me the correct answer. Number 3, we take dash when we are sick. Juice, soda, medicine. So you select for me the correct answer. And lastly, it is dash to share medicine. Good, bad. Select the correct answer and fill in the blank space. So finish the assignments and make sure that you are going through your work. Hope to see you in the next lesson when you are of good health. Goodbye.
Welcome to Manifested Publishers.
Hello learners, welcome again to Manifested e-learning platform. I'm Teacher Purity and welcome to this online lesson, and we are still learning English for grade 2. The topic is still language structure, and under language structure we are going to talk about the use of the verb were. So this is the same thing we discussed in our previous lesson. We still learn the use of the verb were. So we are still going to learn it again because maybe you have forgotten or there are people who did not understand. So welcome to the lesson and hope you are going to enjoy. So we are learning English. So under language structure, we had started on the use of the verb were. The use of the verb were. Now, if you can remember, during our previous lesson, we learned the use of the verb were, and we said that were is used in the past tense to represent when you are talking about something that is done by another person or other people. So wa is used to represent something done by another person who is one or other people. So we use wa. We use the verb wa to we use the verb wa when talking about something, when referring to something. When referring to something done by another person or other people. So we use the verb wa when referring to something done by another person or other people. Now let's understand what we are saying by talking about another person. When we are talking about another person, we use the pronoun you. You represents another person. You are not the one, but you are talking about something that another person has done. Then other people. Now other people can be represented by they. They were going to the school. They represents other people who are more than one. We can still use the verb wa with the pronoun we. We is used in plural, and when you use we, it means you are among those people who have participated in a certain activity or who have done a certain task. So the verb wa is used when referring to something done by another person or other people. Another person is represented by you. So let's see how we can use the verb wa in examples. So examples can have the first one. You are sweeping the house. Example 1, you are sweeping the house. Now you is representing another person. You are talking about another person who was sweeping the house. Another example can have you are playing in the rain. You are playing in the rain. So you are talking about another person who was playing in the rain, and it is something that already happened in the past. Now we have said that the verb wa is used when referring to something done by another person, which is represented by you or other people. Under other people, I've said you can use they or we. We is when you are among those people. Now let's see how we can use the verb wa with the pronoun we. So you can have an example. We were sitting under the shade. Under the tree, not under the shade. Under the tree. We were sitting under the tree. This means that you are among those people who were sitting under that tree. We can still have another one. We were fetching water. We were fetching water. You are among those people who went to the river to fetch water. And lastly, we have they. They now, you are talking about other people. You are not among those people. So you can have a sentence like, they were singing a song. They were singing a song. You are telling us about other people who were singing a song. Can also have another one. They were planting the crops. They were planting the crops. You are telling us about other people who were planting the crops. Now, this is what we learned during our previous lesson, the use of the verb were, where it is used when referring to something done by another person or other people. And the examples, number one, you were sweeping the house. You, which is used to refer to another person. Example 2, you were playing in the rain. Example 3, we were sitting under the tree. Now, under we were sitting under the tree, you are talking about people and you are among those people doing the activity. Number 4, we were fetching water. You are among those people who went to fetch water. And number 5, they were singing a song. They were singing a song. They is used when talking about other people who have done something. So these particular people here were singing a song. You are telling us what they did in the past. And lastly, they were planting the crops. You are talking about people who are planting the crops. They already planted them. So you are now telling us what they did. So this is what we discussed during our previous lesson. And after the lesson, I gave you assignments. I want us to quickly go through the assignment. We shall go through the assignment on the board. So as we go through the assignment, check your answers with what you shall have on the blackboard. If you are having the wrong answer, please don't correct during the lesson. You shall do correction after the lesson. So let's go through the work. So we are still under language structure. And talking about the use of the verb were. The use of the verb were. So let's go through the work that I gave you. Now, the instruction were, fill in the gaps using the verb were. in the gaps using the verb were. So the instructions are clearly telling us to use the verb were to fill in the blank spaces, or rather the dashes. So number 1 was we dash playing outside. We dash playing outside. We dash playing outside. Now, from the instructions, you have been instructed to fill in the gaps using the verb were. So you'll come and fill in the gap with the verb were. After filling in the answer, you read the whole sentence with the answer. So your sentence should read, we were playing outside. We were playing outside. Question 2 was, you dash crying loudly. You dash crying loudly. So fill the gap with the verb were. Then you read the whole sentence again with the answer. So your sentence should read, you were crying loudly. You were crying loudly. That particular person was crying out loudly. Question 3 was, you dash washing the classroom. You dash washing the classroom. So fill the blank space with the verb were and read the whole sentence. So you were washing the classroom. Your sentence should read, you were washing the classroom. Question 4, you dash taking your lunch. You dash taking your lunch. So you fill the blank space with the were. Then you read the whole sentence. You were taking your lunch. And the last one was, they dash playing in the rain. Number 5. They dash playing in the rain. They dash playing in the rain. So fill the blank space again with the verb were. After that, you read the whole sentence with the answer, so that your sentence should read, they were playing in the rain. They were playing in the rain. So this is how you are supposed to go through your assignment that I gave you during the previous lesson. Check your work. Confirm if your answers are the same as what I have on the board. And if you do not have the correct answers, please do corrections before you continue with the work that I will give. But if you have scored everything, just continue with what I will give. So for the ones that have corrections, please do corrections. And it shows that you have tried. It is not bad to wrong. It is very fine because you are learning. The ones who have scored everything, that is good work. So just finish the corrections if you have them and copy the questions. If you do not have the corrections, kindly copy the assignments that I am going to give. So let's go through the work that I've given you. The instruction says fill in the gaps with the verb were. So now you are going to fill in the gaps. The gaps are the dashes using the verb were. Question 1, Mwangi and Otieno dash playing in the bush. Question 2, they dash washing the dishes. Number 3, Mary and Nafula dash drawing. Mary and Nafula dash drawing. Question 4, you dash reading a storybook. And lastly, father and mother dash going to the market. So copy these questions and you do them. The ones who have corrections, make sure that you finish the corrections first before you do the work that is on the board. So finish your work, and after answering your work, make sure that you read through your work, you go through the questions. You can correct small mistakes that you might have committed. So happy to have you for today's lesson. Hope to see you in the next lesson. Goodbye.
Thank you for choosing to study with us. For more information, you can call us on 0724 173845.
Hello learner, welcome to Manifested e-learning platform. My name is Purity Anzelimo, and our subject today, what I'll be taking us through, is physics. Yes, and during our lesson today, we are going to look at electromagnetic spectrum. Electromagnetic spectrum is a topic in book 4. That is what we are going to look at during our lesson. So we have the electromagnetic spectrum. And as I've said, is one of the topics in book 4. And this we are going to relate a lot with what we covered in book 2 under the topic waves. So we are going to borrow a lot from the topic waves in book 2 and also in book 3. Yeah, because as you can see, we have the electromagnetic spectrum, and in book 2 we learned about the electromagnetic waves. So by the end of this lesson, you should be in a position 2. So we have the objectives for this lesson. You should be in a position 1 to describe fully a complete spectrum. That is a complete electromagnetic spectrum. You should be in a position to explain what an electromagnetic spectrum is. So by the end of the lesson, you should be in a position to explain the electromagnetic spectrum. Electromagnetic spectrum. That's 1. And number 2, by the end of this lesson, you should be in a position to state the properties of electromagnetic waves. State the properties of the electromagnetic waves. State the properties of the electromagnetic. We abbreviate it as EM, electromagnetic waves. So that is what you should be in a position to, by the end of the lesson, explain the electromagnetic spectrum. What is an electromagnetic spectrum, as we have our topic, and what are the properties of the electromagnetic waves. So to begin with, we are going to deal with, or we are going to define what we are calling the electromagnetic waves, so that we can be able now to define what an electromagnetic spectrum is all about. So we are going to start with electromagnetic waves. Electromagnetic waves. So from Waves Book 2, what are electromagnetic waves? When we talk of electromagnetic waves, we say that these are waves that do not require a material medium for their transmission. They are waves that do not require a material medium for their transmission. That is simply what we refer to as the electromagnetic waves, or what we call the EM waves. They are waves that do not require a material medium for their transmission. Remember, we gave two categories of waves in Form 2, whereby we looked at the electromagnetic waves and the mechanical waves. And one of the major differences between the electromagnetic waves and the mechanical waves is that for the electromagnetic waves, they do not require a material medium for their transmission, whereas for the mechanical waves, they require a medium for their transmission. And these electromagnetic waves, again, we can define it as, because we say that all electromagnetic waves are transverse in nature. Remember that all the electromagnetic waves are transverse. They are transverse in nature, meaning that the vibration of their particles is at right angle to the direction of wave travel. And therefore, we can also say that electromagnetic waves, we can say that they are produced by the oscillating electric and magnetic fields at right angle to each other. So we can say that they are produced, or they are formed by the oscillating, they are formed by the oscillation or the oscillating magnetic and the electric fields at right angle with each other. So those are the EM waves. We have seen that they can be transmitted through a vacuum because they do not require a material medium for them to be transmitted. Then we are also saying that all the electromagnetic waves are transverse in nature. And we are saying, therefore, it means that the vibration of their particles is at right angle to the direction of the wave travel. And that's why we are saying that they are produced by the oscillating magnetic and electric fields at right angle with each other. So these are the electromagnetic waves, or the EM waves. Now we need to list down those electromagnetic waves that we are talking about. So we list down, they include the electromagnetic waves, or the EM waves include. So we have various, or we have electromagnetic waves, examples of electromagnetic waves. We can list them down in any order. We have what we call the gamma rays. Gamma rays is an example of an electromagnetic wave. We also have what we call the microwaves. The microwaves. We also have the visible light. The visible light. We also have the infrared radiation. The infrared radiation. We also have the ultraviolet radiation, or what we call the UV radiation. The ultraviolet radiation. We also have what we refer to as the X-rays. We have the X-rays as an example of the electromagnetic waves. We have the X-rays. So we have the gamma rays, we have the microwaves, we have the visible light, we have the infrared radiation, we have the ultraviolet radiation, and we also have the radio waves. Radio waves. So these are our electromagnetic waves. Remember where we have come from? We want to define an electromagnetic spectrum. And we have started by asking ourselves, what are these electromagnetic waves? And we are saying these are waves that are produced by oscillating magnetic and electric fields at right angle with each other. And we have the list of the electromagnetic waves. We have the gamma rays, we have the microwaves, we have the visible light, we have the infrared radiation, ultraviolet radiation, we also have the X-rays, and we also have the radio waves. Now all these waves that we have listed down are what we are calling the EM waves. And these waves, as we have seen, they are transverse in nature, meaning that also they have sections of crests alternating with troughs. That is what we said in book 2 on waves, that when we talk of a transverse wave, it has sections of crests alternating with troughs. And note that all these electromagnetic waves, we are saying that they are waves in nature. And therefore, when it comes to the properties of the electromagnetic waves, we'll also be looking at some of the properties of waves as learned in book 3 under waves 2. So we have these electromagnetic waves. Now, the way they have been arranged, they have been mixed up. There is no formula that I've used to arrange these electromagnetic waves. But now we can arrange these waves in order of their wavelengths or their frequencies. If we arrange these electromagnetic waves in order of their frequencies or in order of their wavelengths, then we are going to form what we call an electromagnetic spectrum. And that's what I want us to do. So we want to arrange these electromagnetic waves, the waves that we have listed down, we arrange them in order of their frequencies or in order of their wavelengths. Remember those two terms, wavelength and frequency. Wavelength, always represented by a Greek letter lambda, and then we have the frequency. Frequency represented by a small letter f. So we have wavelength, and we say that wavelength simply refers to the distance covered in one complete oscillation. So remember that distance covered in one complete oscillation is what we are calling the wavelength. And we say that the SI unit for wavelength is meters. That is the SI unit because it is distance, and distance is length, and the SI unit of length is meter. Then we have frequency, and when we talk of frequency, it simply refers to the number of complete oscillations in 1 second. Number of complete oscillations in 1 second. And we say that the SI unit of frequency is hertz. So that's what we have. Now we want to arrange these electromagnetic waves in order of their wavelength and in order of their frequency. So we start with the one that has the smallest frequency, and we have what we refer to as the radio waves. It has the lowest frequency or the smallest frequency, followed by the microwaves. We have the microwaves, followed by the infrared radiation. We also have now the visible light. Visible light. Then we have the ultraviolet radiation. Then we have the X-rays. And finally, we have gamma rays, which have the highest frequency. We have the gamma rays. So if I were to draw an arrow to indicate the increasing frequency, so this is increasing frequency. So we have radio waves. They have the lowest frequency all the way to gamma rays. So gamma rays have the highest frequency. But now when it comes to wavelength, these two are inversely proportional. when it comes to the wavelength, if we have this as the increasing wavelength, then it means that when we'll have it this way now for the wavelength. For the wavelength, we have gamma rays, which have the lowest wavelength. So we have increasing, so we have the increasing wavelength. So you should be keen. We have gamma rays. Gamma rays have the highest frequency, but have the lowest wavelength. They have the highest frequency, but have the lowest wavelength. Then the radio waves have the highest wavelength. The radio waves have the highest or the largest wavelength, but they have the lowest or the smallest frequency. So that is it. So when these electromagnetic waves have been arranged in order of their frequency or in order of their wavelengths, then what they form is what we refer to as an electromagnetic spectrum. So this that we have here, the radio waves, the microwaves, the infrared, the visible light, the ultraviolet radiation, the X-rays, the gamma rays, the way they have been arranged is what we refer to as an electromagnetic spectrum. So for an electromagnetic spectrum, so for the electromagnetic spectrum, we have the following electromagnetic waves. We have seen that when the electromagnetic waves have been arranged in order of their frequency or in order of their wavelength, they form an EM spectrum. So they can be either maybe the increasing frequency or the decreasing frequency, or the increasing wavelength or the decreasing wavelength. So provided they have been arranged in a certain order of their frequencies or their wavelengths, then we'll say that they form an electromagnetic spectrum. So our electromagnetic spectrum, we are going to have, therefore, if we start with the one that has the lowest frequency, that is the radio waves. So we are going to have radio waves. We have the microwaves. We have the infrared radiation or the infrared. We have the visible light. The visible light. We also have the ultraviolet radiation. We also have the X-rays. And finally, we have the gamma rays. So all these arranged in this order, they form an electromagnetic spectrum. And therefore, we can be able to define what an electromagnetic spectrum is. So an electromagnetic spectrum is simply electromagnetic waves arranged in order of their frequencies or wavelengths. So these are electromagnetic waves. It refers to the electromagnetic waves arranged in order of their frequencies or wavelengths. Electromagnetic spectrum refers to electromagnetic waves arranged in order of their frequencies or wavelengths. And as we continue, we'll be able to see, now that we are seeing that radio waves have the lowest frequency, gamma rays have the highest frequency. Therefore, we'll be able to see that therefore the 2 or the 7 electromagnetic waves have different energies, or they possess different amounts of energy, because energy depends with the frequency and also the wavelength. So that is the electromagnetic spectrum. So if you are told to define what an electromagnetic spectrum is, then it simply refers to the electromagnetic waves arranged in order of their frequencies or wavelengths. And we'll continue and get now to the properties. So those are the that is the electromagnetic spectrum. and you should also be in a position to arrange all those electromagnetic waves in order of their wavelengths or in order of their frequencies. So if you know one, for example, you know that the radio waves have the smallest frequency, followed by microwaves all the way to gamma rays. So if you know one of them, the frequency, then you should know that the wavelength is the vice versa, the other way around. So if the radio waves, we are saying that they have the smallest frequency, then it means that they have the largest wavelength. Gamma rays have the highest or the largest frequency, and they have the lowest wavelength. So make note of that, because you can be given in an exam, you are given examples of some electromagnetic waves and you are told to arrange them maybe in order of their increasing wavelength or maybe in order of their decreasing frequency. So make note of that. Then something else I want to emphasize on before we go to the properties of the EM waves. At this point here, the visible light, when we talk of this visible light, as you learned in reflection of light, the dispersion of white light, the visible light comprises of the 7 colors of the rainbow. So here in the visible light is where we have the colors like the red, and we have the rich, and so in the visible light, we have the richant of York gained Barton in vain. So we have the red, we have the orange here, we have the yellow, we have the green here, we have blue, we have indigo, and we have the violet color. So in case maybe you are told that blue light, for example, you are told arrange the following in order of their increasing frequencies. And you are given, for example, infrared, microwaves, X-rays, and you are given blue light. You should know that blue light is one of the visible light, or it's invisible light, because that's what we learned in refraction of light. That's the dispersion of white light, which comprises of the 7 colors of the rainbow. So that is all on the electromagnetic spectrum. You need to know how to arrange these waves in order of their frequencies and wavelengths. So I want us to move on and look at the properties of these waves. Yeah, because we are saying that they are waves in nature, they are transverse waves in nature. So we have various properties of the electromagnetic waves. So let's look at the properties of electromagnetic waves. Properties of electromagnetic waves. And one of the properties that we have just stated when I was introducing the lesson, we have seen that number 1, the electromagnetic waves are transverse in nature. They are transverse waves. So number 1 is that they are transverse in nature. They are transverse in nature. So the EM waves are transverse in nature, and we have seen that they are produced by the oscillating magnetic and electric fields at right angle with each other. So that is one of the properties. Then we have also seen that the electromagnetic waves do not require a material medium for their transmission. So that is another property, that they do not require a material medium for their transmission. And therefore they can also be able to be transmitted through vacuum or through space. So they do not require a material medium for their transmission. Something else that you need to note about the electromagnetic waves. Electromagnetic waves travel with the speed of light. They travel with the speed of light. And the speed of light, that is the speed of light is 3 times 10 power 8 meters per second. So that is another property. They travel through space with the speed of light. They travel with the speed that is 3.0 times 10 power 8 meters per second. So if you are given a question, because we'll now also get into numerical calculations, when you are told, for example, infrared radiation, and you are told maybe to calculate, for example, maybe the energy, you have not been given the speed, always know that the speed of any of the electromagnetic waves is 3.0 times 10 power 8 meters per second. That is for all those electromagnetic waves. So they travel with the speed of light, which is 3.0 times 10 power 8 meters per second. Then something else, because we are saying that these waves, we are saying that they are waves, and therefore they will undergo the following. So they undergo, since they are waves, they undergo diffraction. You talked about diffraction in waves 2. They also undergo reflection. They also undergo interference and polarization effects. All these are properties of waves. They undergo diffraction, reflection, interference, and polarization effects. And because these EM waves are also waves, they will also undergo the same. So they undergo diffraction, reflection, interference, and the polarization effects. Then we can also say another property is that they will possess energy. As I had mentioned earlier, we are saying that they have different frequencies. They have different frequencies. Gamma rays having the highest frequency and radio waves having the smallest frequency. So we can also say number 5 that they possess energy. They possess kinetic energy. We can talk of kinetic energy in different amounts depending with the, just talk of energy. They possess energy in different amounts. We are going to do the calculations. You will get the formula that we use to know which one contains higher amount of energy than the other. We'll get to that in our next lesson. So they possess energy in different amounts. And we have seen that since the gamma rays have the largest frequency, they will actually have the highest amount of energy. So just know that they possess energy in different amounts. Then finally, we can say that they carry no charge. Number 6, they carry no charge. And therefore, they are not deflected by either the magnetic or the electric fields. So they are not, we can say that they are not affected by electric and magnetic fields. They carry no charge. So they are neither positively nor negatively charged, but they carry no charge with them. And therefore they are not affected by either the electric, we can add by either, they are not affected by either the electric or the magnetic fields. And those are the properties of the EM waves. We have said that they are transverse in nature. In book 2, you learned what are transverse waves. Transverse waves are waves whose vibration of particles is at right angle to the direction of wave travel. Number 2, they do not require a material medium for their transmission. They can be transmitted through a vacuum. Number 3, they travel with the speed of light, which is 3 times 10 power 8 meters per second. Number 4, waves, they will undergo diffraction, reflection, interference, and polarization effects. And number 5, they possess energy in different amounts. And when we come to the uses of the electromagnetic waves, we'll be able to state the uses depending with also the amount of energy that the electromagnetic wave possesses. Then finally, number 6, we have seen that they carry no charge, and therefore they are not affected by either the electric or the magnetic fields. So that is on electromagnetic spectrum. I would like to do an exercise. Number 1, state 5 properties of the EM waves. State 5 properties of the electromagnetic waves. Number 2, arrange the following in order of their wavelengths. Arrange the following in order of their wavelengths. So we have the following EM waves. We have infrared, green light, ultraviolet radiation, radio waves, and X-rays. So we have the following: infrared, green light, ultraviolet radiation, radio waves, and the X-rays. Arrange them in order of their wavelengths. Then question number 3. Question number 3. Why is sound not an electromagnetic wave? Why is sound not an electromagnetic wave? We know that sound is also a wave, but we are asking, why is sound not an electromagnetic wave? Number 4. Question number 4. Name one radiation of electromagnetic spectrum. Name one radiation of electromagnetic spectrum which has a higher frequency. Name one radiation of EM spectrum which has a higher frequency than the visible light. Which has a higher frequency than the visible light. So name one of it which has a higher frequency than the visible light. And finally, number 5, give two differences. Give two differences between electromagnetic waves and mechanical waves. Give two differences between electromagnetic waves and mechanical waves. So you give two differences between the EM waves and the mechanical waves. Differences between the EM waves and the mechanical waves. So that is all on our lesson today. We have been able to achieve the two objectives that we had. One, to define an electromagnetic spectrum, which we have said an electromagnetic spectrum simply refers to the electromagnetic waves arranged in order of their wavelengths or frequencies. Then number 2, we've also been in a position to state the properties of the EM waves. And they are here. We have said they are transverse in nature, They do not require material medium for their transmission, travel at the speed of light, undergo diffraction, reflection, interference, and polarization effects. They possess energy in different amounts, carry no charge, and hence not affected by either the electric or the magnetic fields. So that is it. When you do this exercise, you'll be in a position to see whether you have captured the lesson well. And during our next lesson, we'll now be calculating this energy. Now that we are saying that they possess energy in different amounts, we'll now be able to calculate the energy that is possessed by the electromagnetic waves. Thank you for following. Till we meet next lesson.
Welcome to Manifested Publishers.
Hello learners, welcome to our today's lesson. We are learning chemistry form 2. The topic is chemical families and patterns in properties. In our previous lesson, we discussed the reaction of alkali metals with water, where we say that when alkali metals react with water, they lead to formation of an alkaline solution, that is hydroxides of these metals, and hydrogen gas is produced. So I hope you still remember those reactions. You can be able to write the chemical equation. But still remember that I left with the assignment, and the assignment was to write balanced chemical equations for the reaction between lithium and water, sodium and water, and reaction between potassium and water. I hope you have done that. In this lesson, we are going to look at or discuss the reaction between alkali metals and chlorine gas. So reaction between alkali metals and chlorine. Therefore, I will start by maybe giving you a small demonstration or illustration on that. So experiment. And the aim of this experiment is just ask yourself the reaction, or is the reaction between sodium and chlorine. Reaction between sodium and chlorine. So if we have a simple procedure, the procedure would be first you cut a small piece of sodium metal and put it on a diffragrating spoon. So cut a small piece of sodium metal and place it or put it on a diffragrating spoon. Remember, we said that alkali metals are reactive metals, and therefore you should use small pieces. Diffragrating spoon, I hope you still remember in Form 1, this was one of the apparatus we learned in Form 1, and they say that a diffragrating spoon is used for holding substances as they are being burnt. So diffragrating spoon. Then warm the piece of sodium. Warm the piece of sodium and lower it into a gas jar containing chlorine gas. So after warming the piece of sodium metal which is on a deflagrating spoon, they are supposed now to lower it into a gas jar containing chlorine gas. There's a disclaimer here, there's a precaution. This experiment should take place in a fume chamber or on an open place. The reason is chlorine gas is very poisonous. Chlorine is a poisonous gas, and therefore this experiment should take place in a fume chamber or in an open place. Remember, this chlorine can affect your respiratory system, and therefore that is why you should not come into contact with it. So carry the experiment in a fume chamber. When sodium, or the warm piece of sodium metal which warmed on a deflagrating spoon, then you lowered it into a gas jar containing chlorine, then a reaction is going to take place, and this reaction will lead to, the reaction leads to formation of white fumes. The reaction leads to formation of white fumes, and the white fumes is now sodium chloride. Then the equation for the reaction will be sodium reacts with chlorine gas, leading to formation of sodium chloride solid. Therefore, to balance the equation, you need a 2 and another 2. Therefore, the color of sodium chloride is white. That is the color of sodium chloride. It is white in color. So that's what happens when you do this experiment. Remember again, I've told you that always use small pieces of these metals because sodium is a very reactive metal, and it is highly reactive. Remember again, in the previous lesson we said it is very vigorous, or the reaction is more vigorous. Therefore, it can even explode into a flame, and therefore use small pieces. And remember always, experiments involving poisonous gases should take place in a fume chamber. So therefore, that is how sodium reacts with chlorine gas, and that's what I wanted you to understand in this lesson. In the next lesson, we are going to discuss the reaction between chlorine and lithium, and also the reaction between chlorine gas, and write a balanced chemical equation for the reaction between chlorine gas and sodium metal. Chlorine gas and sodium metal. So write a balanced chemical equation. Write a balanced chemical equation for the reaction between chlorine gas and sodium metal. The next lesson, we are discussing the reaction between lithium and chlorine, and also potassium and chlorine. Meet you in the next lesson.
Welcome to our physics lesson today. My name is Purity Anzelimo, your teacher of physics. In our lesson today, we continue with the cathode rays and the cathode ray tube. That's our topic. Cathode rays and the cathode ray tube. During our previous lesson, we have been looking at the parts of a cathode ray oscilloscope, and we were able to know that a cathode ray oscilloscope is used in the production of cathode rays, and we were able to see the three major parts of a cathode ray oscilloscope, namely the electron gun. We also have the deflecting system and also the screen or the display system. So those were the major parts, or those are the major parts of a CRO. In the electron gun, we have the cathode, that is the heated cathode, the ground, and the anodes. In the deflecting system, we have the X plates and the Y plates. And in the display system, we have the screen. So during our lesson today, we continue with the cathode ray oscilloscope, but now we want to look at the uses of a CRO. So uses of a CRO, uses of a cathode ray oscilloscope. And we are going to look at two major uses of a cathode ray oscilloscope. We are going to explain each one of them. So one of the uses of a cathode ray oscilloscope is used as a voltmeter. So number one, used as a voltmeter. A cathode ray oscilloscope is used as a voltmeter. We know from the topic current electricity, we know that a voltmeter is a device that is used to measure voltage. So we have the CRO being used to measure voltage. So we are going to explain how. Then again, we can use a CRO to determine the frequency of an alternating current signal, used in determining the frequency of an alternating current signal. So we will also explain how a CRO can be used to determine the frequency. Remember, we know what frequency means. When we talk of frequency, simply refers to the number of complete oscillations in 1 second. So it can also be used in determining the frequency of an alternating current signal. So I want us to start with the first one. We have seen that a cathode ray oscilloscope can be used as a voltmeter. So CRO as a voltmeter, our CRO as a voltmeter. And we are going to see that the cathode ray oscilloscope will have many advantages over the voltmeters that we use, the ordinary voltmeters that we have. So when we are using the cathode ray oscilloscope as a voltmeter, when the time base is switched off, with the time base switched off, when we have our time base switched off, then we also have the X plates being at, X plates at, and then we have and the voltage to be measured, connected, and voltage to be measured, connected to the Y plates. So this is what we are going to have. So when we have the time base switched off, remember we said that the time base is connected to the X plates, and now we want to, and the X plates are at, and then we have the voltage to be measured, connected to the Y plates. Then we are going to have that the voltage, these are the Y plates. Remember we said there are two. So the voltage will be given by the displacement multiplied by the sensitivity. And in the sensitivity, that is simply the volts per division. Sensitivity is simply the volts per division. So when we have the time base switched off, the X plates at and the voltage to be measured connected to the Y plates, then we can calculate the voltage as displacement. Remember, we said that in the deflecting system, we have these Y plates which are responsible for the vertical deflection. And that's why we are talking of the displacement. We are going to apply this in our numerical calculations. So voltage will be given by the displacement multiplied by the volts per division. And in this volts per division is also referred to as the sensitivity. So that's how we can use a CRO to calculate the voltage, or that's how a CRO can be used as a voltmeter, and we are going to employ this in our calculations. So note voltage is equal to displacement multiplied by the volts per division. And as I've said, a voltmeter is a device that is used to measure voltage. And therefore we have our other voltmeters, the ordinary voltmeters. But now we are saying that the CRO is advantageous or has more advantages of the ordinary voltmeter. And we look at those advantages. So we look at advantages of the CRO over the voltmeter. Advantages of the CRO over the ordinary voltmeter. Now, a CRO as a voltmeter, we have seen that it can be used as a voltmeter. What are the advantages of the CRO when used as a voltmeter over the ordinary meters? So one of the advantages is that it can be used to measure both direct current and alternating current voltages. That's number one. Remember, for the voltmeters that we have or that we use in the lab, mostly they are only used to measure direct current voltages. So but for the CRO, can be used or can measure both the direct and the alternating current voltages. So that's one of the advantages of a CRO over the voltmeter. Then we can also say that it can also be used to measure large currents. It can be used to measure large, not currents, but voltages, because it's used as a voltmeter. It can be used to measure large voltages without being destroyed. We know in the voltmeters that we use in the laboratory, most of them ranges from 0 to 5 volts, others from 0 to 3 volts. But now for the CRO, it can be used to measure larger voltages. So can measure larger voltages compared to the ordinary voltmeters. So it can be used to measure larger voltages compared to the ordinary meters, and it cannot be destroyed. So without being destroyed. Without being destroyed. That is another advantage of a CRO over the ordinary voltmeters. Then we know very well when we are using the voltmeters, that is in electricity, when we use the voltmeter, when you want to read the screen or the reading, we usually check where the pointer, how the pointer moves. If, for example, this is my pointer, these are the readings here on the voltmeter. We know very well that this pointer, when you want to get the reading, it swings fast. It swings around the reading. It swings and then it points where the reading is to be. And the reason as to why it swings before getting to the point where the reading is due to inertia. Due to inertia. which we discussed also in the Newton's laws of motion. So as a result of inertia, then this pointer will swing momentarily about the point or the actual reading. But for a CRO, it's not affected by inertia, and therefore the reading will just be read directly instead of the pointer having to swing about the point where the reading is to be taken. So that is another advantage of a CRO. So we can say that it responds at an instant or instantaneously responds instantaneously. The response instantaneously, unlike the ordinary meters which swing, or which, unlike the ordinary meters, we can talk of whose pointers are affected by inertia. So they will sing about the point and before they show the actual reading. But now for a CRO, it will respond instantaneously, unlike the ordinary meters, which we are saying the pointers are affected by inertia. Then we can also say that with the CRO, another advantage over the ordinary meters, another advantage, number 4, we can say that the CRO has a very high resistance. It has an infinite resistance, and therefore it does not take any current. It has very high resistance, any current. It has a high resistance, hence does not take any current. From current electricity, that is on Ohm's law, we know very well that Ohm's law relates voltage to resistance, that is V is equals to IR, and we are saying that a CRO has a very high resistance. This is very high for a CRO, and that means when it is high, it is not going to take any current or even any voltage. The voltage and the current are not going to be affected when the value of the resistance is high, because from this we know that the current will be equal to V all over R, and we are saying that when this is very high, then it's not going to affect this current. It's not going to take any current, because if it were low, it means that then this will be affected, the current will be affected for us to get the voltage, because it's being used to measure the voltage. So it has a high resistance, or what we are calling infinite resistance, and therefore it does not take away any current. So those are the uses of a CRO. That the first use, which we have just discussed, that it is used as a voltmeter, and we are saying that when the time base is switched off and the X plates are at, the voltage can therefore be measured, or can be measured while connected to the Y plate. And voltage, we have seen, will be given by the displacement multiplied by the volts per division. And then we have also explained why the CRO is preferred to the ordinary voltmeters. It has the following advantages. We have mentioned 4 of them. It can measure both direct current and alternating current voltages, unlike the voltmeter, which only measures the direct. Then it can measure larger voltages compared to the ordinary voltmeters without being destroyed. We have also seen that it is not affected by inertia, so it can respond instantaneously, unlike the other meters. Then we've also seen that it has infinite resistance, and hence it does not take any current away. So we want to look at the other use of a CRO, use number 2, where we have seen that it is used in determining the frequency of an alternating current signal. So used to determine the frequency, CRO to determine the frequency used in determining frequency that is of an alternating current signal. And in this one, the signal is fed into the Y plates. The signal is fed into the Y plates. The signal is fed into the Y plates with the time base on. The time base is on, with the time base on, and we are saying that the time base control is then adjusted. The time base is controlled. The time base can be controlled. The time base control, is adjusted to give one. It is adjusted. The time base control is adjusted. So this time base, remember, it is on the X plate, is adjusted to give many cycles as possible. It is adjusted to give more cycles, So remember, in this, we are going to have the formation of the cycles. We can have it here. So there will be formation of the cycles. So we can have this. That's what we are going to have. So we are saying that when the time base is on, and this time base control is adjusted to give more cycles, and therefore from this, then we can say that when we want to calculate the frequency, the periodic time is recorded. The time, or what we call the periodic time is the time taken to complete one cycle. This time which is taken to complete this cycle, the time which is there, is what we are calling now periodic time, represented using a capital letter T. And we can say that the periodic time is determined. It is determined by relating the trace of the signal by relating the trace of the signal on the screen with the time base setting. So the periodic time is now being determined by relating the trace of the signal, which you have seen, the trace of the signal on the screen with the time base setting. So we can be able now to get the periodic time, because we are saying that the time base is on. So when we get the periodic time, then we can now be able to calculate the frequency F. By the formula, frequency is simply the reciprocal of the periodic time, T. And therefore, we can be able to calculate frequency by getting the reciprocal of the periodic time. So that's how we can use a CRO to determine the frequency of an alternating current signal. Because when we get the periodic time from the connections, whereby we are saying the signal is fed into the Y plates, then the time base is on, the time base control is adjusted to give cycles many as possible, and therefore the periodic time is determined by relating the trace of the signal, this is the signal on the screen, with the time base setting. So with this, we can be able to get the periodic time, and hence able to calculate the frequency. So the frequency will be the reciprocal of the periodic time. So those are the two uses of a CRO. One used as a voltmeter, and we have seen that the voltage here will be given by the displacement multiplied by the divisions, that is the sensitivity. And then we have also seen that it is used in determining the frequency of an alternating current signal. So those are the two uses, and you should be able to explain how it is used. In this, we are going to do more calculations. We'll apply this formula in our calculations. We'll also apply the formula on calculation of voltage, which we have seen being given by displacement multiplied by the sensitivity. So we want now to compare a cathode ray oscilloscope to a TV tube. We want to look at the differences that are there between a cathode ray oscilloscope and the TV tube. So we look at those differences. So differences between a CRO and a television tube. So what are the differences between the two? Differences between a cathode ray oscilloscope and a TV tube. So we can just have a table. On one side we can have the TV tube, and on the other side we have the CRO. So this is our TV tube. Then on the other side we have the CRO. So we want to see what are the differences between a cathode ray oscilloscope and a television tube. So one of the differences for a television tube, the deflection here, the deflection is by magnetic field. Whereas in a CRO, the deflection is by electric field. So you need to know that in a TV tube, the deflection is by the magnetic field, whereas in a CRO, it's by the electric field. Then a TV tube has two time base. It has two time base. Whereas in a CRO, as we mentioned, it has only one. Has one time base, which we said it's on the X plates. Then we can also say that electrons light the whole screen for a TV tube, and that's why you are able to see the whole screen being lit in a TV. So the electrons light the whole screen. The whole screen. Whereas in a CRO, as we said, the electrons will only form a spot. Electrons form a spot on the screen. This we were able to explain. So the electrons which are being produced in a cathode ray oscilloscope will only form a spot on the screen, unlike in a TV tube where the electrons will light the whole screen. Finally, there are 625 lines per second in a TV tube. There are 625 lines per second in the TV tube, whereas in a CRO, there are only 25 lines per second. So those are the differences, 4 differences between a TV tube and a CRO. In a TV tube, the deflection is by the magnetic field, and that's why the TV screen is larger than a CRO screen. Then we are saying that a TV tube has 2 time base, whereas a CRO has only 1. In a TV tube, electrons light the whole screen. In a CRO, electrons form a spot on the screen. In a TV tube, there are 625 lines per second, whereas in a CRO, there are only 25 lines per second. So that is it on the CRO, or the cathode ray oscilloscope. In the other lesson, which now will mark the end of this topic, we'll now be looking at the calculations involving the CRO. Now that we have seen we can be able to calculate the voltage, we can be able to calculate the frequency, we can be able to calculate the sensitivity. So that's what we'll engage in. So I'd like to give you some exercise on what we have just covered on the uses of a CRO. So an assignment here for you. Answer the following. So that is the exercise. So we are told in question number 1, state one difference between the deflection systems of a cathode ray tube and the TV tube, which we have just explained. Then number 2, the beam of electrons is subjected to a strong magnetic field which is perpendicular to the path and into the paper. Sketch on the same diagram or on the same figure the new path of the electron. Then number 3, when using the cathode ray oscilloscope to display waveforms of voltages, state where the following should be connected. 1, the voltage to be displayed on the screen. And number 2, the time-based voltage. So that's the exercise. It's good that you answer those questions. And during the next lesson, we'll now look at the numerical calculations involving the cathode ray oscilloscope. Thank you.
Welcome to Manifested Publishers.
Hello learners, welcome to this lesson. It is Chemistry Form 2 and the topic is Chemical Families and Patterns in Properties. If you remember in the previous lesson, we discussed the chemical families and we discussed a brief about the alkali metals. We said they are also called group 1 elements, and we also wrote the electron arrangement of the first 3 group 1 elements. Lithium was the first element. We said the configuration is 2, 1 because it has 3 electrons. The second was sodium. The configuration was 2, 8, 1. And the third was potassium. And the configuration was 2, 8, 8, 1. Since that the reason why they are called group 1 elements is because they are having 1 electron in the outermost energy level. And the 1 electron enables them to be placed in group 1. If you look at those 3 elements, that the sizes are different, that lithium is the smallest and potassium is the largest, depending on the number of energy levels which are present. That lithium has 2 energy levels occupied by electrons, sodium has 3 energy levels occupied by electrons, and potassium is the largest with 4 energy levels which are occupied by the electrons. And therefore, that's why we are saying that the size of potassium is larger than the size of sodium, and the size of sodium is larger than the size of lithium depending on the number of energy levels which are occupied by electrons in each atom or in each element. In this lesson, I want us to discuss the gradation in size of atom and ion. Gradation in size of atom and ion. Remember, this is gradation in size of atom and ion of alkali metals. So gradation just means there's a systematic progression. A systematic progression on the size of atom and ions in group 1 elements. And I will explain this using a table which I'm going to draw for you so that we discuss it from there. This table is having the element. Therefore, that is the table. I want us to look at the gradation in size of the atom and the ion of alkali metals. These are the alkali metals. So the alkali metals are lithium, sodium, and potassium. Then their symbols, the letters are not supposed to be touching one another. So we have lithium, sodium, and potassium. Those are the symbols. The atomic number, lithium has atomic number 3. Sodium has atomic number 11, and potassium has atomic number 19. Then writing the electron arrangement, these ones we have already written or we discussed that in the previous lesson. So lithium has configuration of 2,1, sodium 2,8,1, then potassium 2,8,8,1. Then we look at the atomic radius, that the sizes of the atom and the ion, these ones are too small, and hence you cannot be able to measure them in the laboratory because their sizes are too small. You can see the units of measurements, they are nanometers. Nanometers are very small units. You cannot be able to measure them. It's too difficult because their sizes are too small. The sizes of the atoms of these metals or these elements are too small. So you cannot be able to measure them unless under special places. So the atomic radius are measured in nanometers. If you look at the atomic radius, lithium, the atomic radius 0.133. That is the atomic radius of lithium. Then sodium, the atomic radius is 0.157. Potassium, the atomic radius is 0.203. The ionic radius for lithium is 0.060. Then for sodium, the atomic radius is 0.095. And for potassium, the atomic radius, not atomic, but ionic radius is 0.133. If you look at the atomic size and the ionic radius sizes, then both are increasing down the group. So we can say that atomic radius, we need first of all to define what atomic radius is. This is the distance from So atomic radius refers to the distance from the center of the nucleus of an atom to the outermost energy level occupied by the electron or electrons. For example, if this is an atom this is an atom. This is the energy level. This is the nucleus of that atom. Let's say atom is lithium. So the lithium atom, this is the first energy level. The first energy level has 2 electrons, and the outermost energy level has 1 electron, because the configuration of lithium is 2-1. So 2 electrons in the first energy level and 1 electron in the outermost energy level. Therefore, the atomic radius is now the distance from the center of this nucleus to the outermost energy level. So the distance from here to here, that is what we are calling the atomic radius. So refers to the distance from the center of the nucleus of an atom to the outermost energy level occupied by an electron or electrons. So this is an atom of lithium. An atom of lithium looks like that. Then when you talk about the ionic radius, we are referring to the radius of these elements having undergone ionization or having formed ions. And these elements, they form ions by losing 1 electron in the outermost energy level. Group 1 elements So group 1 elements form ions by losing 1 electron in the outermost energy level. Therefore, if they lose electrons, or they form ions by losing electrons in the outermost energy level, they become ions. And when they become ions, then the number of the energy levels are going to reduce. So they are going to be like this. So lithium is an atom. When lithium loses 1 electron in the outermost energy level, then it will be positively charged. And the reason why it is positively charged is because it now has more protons than electrons. It has more protons than electrons. Remember, the atomic number is 3. The atomic number being 3, it means that it has 3 protons and 3 electrons. 3 electrons in the atom. When it forms ions, it has lost the 1 electron in the outermost energy level. So there are more protons than electrons. So the difference is just 1, and that's why it becomes positively charged, because it's that protons are positively charged. Protons being positively charged and electrons are negatively charged. Therefore, the net charge when lithium or any alkali metal loses 1 electron, then they become positively charged. Therefore, the configuration or the electron arrangement of this lithium ion will be 2. Then we have sodium. That sodium, when sodium loses 1 electron, it will also become a sodium ion, just having a charge of a positive, because after losing 1 electron, it has 10 electrons remaining and 11 protons in the nucleus, and therefore the net charge is a positive. Therefore, the configuration will be 2, 8, because it has lost 1 electron in the outermost energy level. For potassium, again it will be potassium ion, and once it loses 1, the configuration will be 2, 8, 2, 8, 8. So those are the electron configuration of ions or group 1 elements when they lose or when they form ions. And they form ions by losing 1 electron in the outermost or from the outermost energy level. So you can see that these were the electron configurations of the ions. These are the electron configurations of These are the electron configuration of atoms. These are the electron configuration of ions. And therefore, you can see that if you look at the atomic radius, or if you compare the atomic and ionic radius, then you can see there is a decrease in the size. But first of all, let us start with the atomic radius. How does the atomic radius of alkali metals compare? How does the atomic radius of alkali metals compare? So the atomic radius of alkali metals increase down the group. Atomic radius of alkali metals increase down the group. This is because there is an extra This is because down the group, there is an extra energy level occupied by the electrons. If you look at the atomic radius, that this is 0.0133, 0.157, 0.203. So there's an increase down the group. And we have explained this by saying that the reason why the atomic radius is increasing down the group, it is because down the group, there is an additional or there is an extra energy level which is occupied by the electrons. If you look at lithium, this has 2 energy levels occupied by electrons. Look at sodium, has 3 energy levels occupied by electrons. And if you look at potassium, it has 4 energy levels occupied by the electrons. And therefore, you can see as go down the group, and going down the group means from up going downwards. So there's an extra energy level occupied by the electrons. So the number of energy levels increase as you go down the group. The next is ionic radius. Ionic radius increase down the group. This is because again, ionic radius increase down the group, and this is also because down the group there is an additional energy level occupied by the electrons. And this one can be explained using what I have written here, that lithium, after forming ions, has been left with 1 energy level. Sodium, after losing 1 electron, has been left with 2 energy levels. Potassium, again, has been left with 3 energy levels. And initially, lithium had 2, sodium 3, potassium 4. So again, as much as all of them have lost, that all the 3 elements, each element has lost 1 electron from the outermost energy level. So still, the ionic radius down the group still increases, because down the group there is increase in an additional, or there's an additional energy level which is occupied by the electrons. And that's why the ionic radius also increases, just like the atomic radius down the group. And the other thing I want us to discuss is comparison between the atomic radius and ionic radius. Comparison between atomic radius and ionic radius. So if you look at the atomic radius and ionic radius, for lithium, the atomic radius is 0.133. The atomic radius of the same lithium is 0.060. So you can see the atomic radius is larger than ionic radius. For sodium, again, atomic radius is 0.157. Then for ionic radius, the ionic radius is 0.095. Again, the atomic radius is larger than the ionic radius. For potassium, the atomic radius is 0.203 and the ionic radius is 0.133, showing you that in alkali metals, all group 1 elements, that the atomic radius is always larger than the ionic radius. And the reason is that atomic or group 1 elements form ions by losing 1 electron from the outermost energy level. Therefore, group 1 elements which we are calling alkali metals form ions by losing 1 electron from the outermost energy level. They form ions by losing 1 electron from the outermost energy level. Therefore, once that 1 electron has been lost, the remaining electrons are pulled much closer to the nucleus. Therefore, so the remaining electrons are pulled much closer to the nucleus due to the higher nuclear charge. What I mean is that once this, the atomic number is 3, for lithium is 3. It forms ions by losing 1 electron. Once it loses that 1 electron, 2 electrons are remaining. 2 electrons are now remaining in only 1 energy level. How many electrons are there in the nucleus? There are 3. So if this is a lithium atom, that here we have 3 protons which are positively charged in that nucleus. So these 3 protons which are positively charged, they are now pulling the 3 electrons in the energy levels. So if 1 electron is lost during ion formation, then 2 electrons are remaining. Therefore, it means that the force 3 protons is pulling 2 electrons is higher than the force it would use to pull the 3 electrons. So there is more force, or the 2 electrons are pulled much closer, or they are pulled more than the 3 electrons. And that's why we are saying that group 1 elements, that they form ions by losing 1 electron from the outermost energy level, and therefore the remaining electrons after ion formation, they are pulled much closer due to the higher nuclear charge at the nucleus. So this higher nuclear charge, and that's why the ionic radius for group 1 elements will always be higher. The ionic radius will always be lower than the atomic radius. Therefore, that is what I wanted you to understand in this. That when you're comparing, then use comparison terms, that the atomic radius is larger than ionic radius, then explain this way, that group 1 elements form ions by losing 1 electron from the outermost energy level, and therefore the remaining electrons are pulled much closer to the nucleus. We would have started by saying that the atomic radius is larger than ionic radius. Therefore, the atomic radius is always larger than the ionic radius because group 1 elements form ions by losing 1 electron from the outermost energy level, and therefore the remaining electrons, they are pulled much closer due to the higher nuclear charge at the nucleus. Therefore, that brings us to the end of our lesson today. But before that, I need to give you the assignment, and the assignment is that's assignment 1, define an atomic radius. So you should be able to define because we have done that. And second, compare the atomic and ionic radius of alkali metals. You should be able to do that. So ensure that you've done that before you meet in the next lesson. In the next lesson, we'll be discussing the physical properties of alkali metals. Thank you for participating in the lesson. See you in the next lesson. Bye.
Enroll your child for the Manifested e-learning platform and see their grades grow tremendously. These videos can be downloaded to a laptop for offline viewing or viewed from a smartphone in a cost-friendly format.
Hello learners, welcome back to Manifested e-learning platform. I'm Philip, your social studies teacher. And we are still in physical environment, covering the map. Physical environment. We are still in physical environment. Physical environment. And in today's session, we shall be majoring on administration. 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 What do I mean by administration? Administration in a map means who's in charge of that area. Remember, each area has to have somebody who is in charge. And those people who are in charge of areas or certain areas of given jurisdiction, we call them administrators. And to start, let us write the administration hierarchy that we have. For instance, if we normally, the smallest hierarchy we have is a village. A village. Many villages makes a sublocation. Sublocation. Many villages makes a sublocation. Many sublocation makes a location. Many location makes a division. Makes a division. Many division used to make a district. But right now, they make what we call a sub-county. Sub-county. And many sub-county, of course, will make a county. And in case you'd want to add another one is that many counties makes a country. Many counties make a country. This is the administration hierarchy. That's the very first thing that we are supposed to know. Maybe before we illustrate whatever we are doing here in a map. This is administration hierarchy, and maybe to give them the titles of the people who are in charge of these hierarchies. Who is in charge of a village? This one is a village headman or elders. Okay, this one depends on the community. Some community have village elders, others have village headmen as the people who are in charge of that village. Sub-location, we have an assistant chief. Assistant chief. We used to call him a sub-chief, but that word sub no longer exists. We use assistant chief. And location, we have a chief. This one still is under a chief. A division was under a DO. That is a district officer. District officer. District officer. District officer. DO. But in the due dispensation, he is called ACC. Assistant County Commissioner. Assistant County Commissioner. Then we have sub-county. Sub-county, we have sub-county commissioner. Sub-county commissioner. Also known as deputy county commissioner. Sub or deputy. Or deputy. Sub or deputy county commissioner. Deputy county commissioner or sub-county commissioner for sub-county. And county, we have county commissioner. County commissioner. County commissioner. And I want to sound a very early warning. When we are talking about administration in the county, we don't talk about the governor. That is the biggest mistake pupils make when it comes to the hierarchy of administration. Administration are the people who represent the national government in an area. And here they are. They represent the national government in an area. They represent the president in an area. In county, who represent the national government? County commissioner, not the governor. The governor is the head of the county, but not the senior administrator. Administrator are the people who represent the national government and the president in an area. So county commissioner is the administrator of the county. Not the head of the county, the administrator of the county. Sub-county commissioner or deputy county commissioner, he's the administrator of the sub-county. District officer or the assistant county commissioner, he's in charge of the division. Chief, in charge of the location. Assistant chief, in charge of the sub-location. Village headman of the village elders, in charge of the village. What are they supposed to do as they represent the national government in those areas? In most cases, they are in charge of security. Security. So who is in charge of security in a village? Village elders. They are the people who are supposed to arrange for the security. In the sub-location, who is in charge of security is the administrator there, assistant chief. Who is in charge of security in a location? It is the administrator of the location. Who is the chief? These people are in charge of security. And it is very, very important to note their work is to provide security in that area. Security. Security in that area. So this is the first step. The hierarchy of the administration. The areas, the administrators. And I'm very specific. I'm not using the name heads. The administrators. Because this one is administration hierarchy. Now, let's go to the map. Using the information here. And we are supposed to know who is the administrator of a map, a given map. So when the question is getting to know the administrator of a certain area, there are two things that can tell you. There are two things that can indicate or can help you identify who is the administrator of an area. Which are those two things, or who are those two people, or which are the two things? Number one, we use offices. Offices or an office. If you want to know who is an administrator of an area, go for the office in that map, in that area. If there is no map, then go for the boundary. Go for the boundary. These two things are the ones that will tell you this area is headed by who? This area is headed by who? Or again, they will also tell you this area is likely to be which area? Is it a location? Is it a sublocation? Is it a county? Is it a sub-county? So let's start from the office. Let's mention something about using an office or offices if they are many in a map. Let me give an example. We have a map here. We have a map here, for instance. We have a map here. This is a very good, very, very good map that we can use to demonstrate. And we have a chief camp there. We have a chief camp there. A chief camp is an office. Now that we want to know the administrator using the office. So who is the administrator of this area? Using the office, we have an office of a chief camp. Chief camp is for a chief. So the person in charge, they are in charge of administering this area is a chief because we have a chief camp. We have used an office. But I have to mention something else about an office. What if there were two chief camps? Our first example, there was only one office, so the administrator was a chief. Now, our second example, we have now two chief camps, or maybe 3 or 4. That means this area is made up of 2 locations because chief is the head of location. 2 chiefs, 2 locations. 2 chiefs, 2 locations. A location, many locations makes a division. So this area is no longer now a location. Let us do like it is a mathematical question. 1 chief camp, this area is headed by a chief because it is a location. That was example number 1. Example number 2, let me use a different color. Example number 2, what if there are 2 chief camp? What if there are two chief camp? A chief camp plus a chief camp, that means that area is a division. A chief camp plus a chief camp, that's a division. Who is the head of a division? A DO. A DO. Or in the due dispensation, ACC, Assistant County Commissioner. Now, another example about the same. What if there was two chiefs camp, and somewhere in the middle or somewhere in the map there is CC, standing for County CCO, County Commissioner's Office. County Commissioner's Office. In that sense, you go for the highest office in that map. You'll not now go for the chief's camps, you'll go for the ultimate, the highest office in the map. So this area, if it has a CCO, that is County Commissioner's Office, this means this is a county and it is headed by a county commissioner. A county commissioner is headed by a county commissioner. These are the three things that you really need to differentiate when it comes to using of an office or offices to know the administrator. We started, if it is one chief camp, the area is a location, the head is a chief. If they are two, you do some mathematical additional. A chief camp plus a chief camp. Or a chief plus a chief, that's a DO. A chief camp plus a chief camp, that's a division. According to the hierarchy. But if there are more than one office, and they are different office, you go for the highest office in the area. You go for the highest office in the area. Now, using a boundary, let's go now to using of a boundary to get the administrator. Using boundaries. Using a boundary. Boundary. Let us now illustrate. We have illustrated how you use an office to get the administrator and the area. Let us now illustrate how to use a boundary. Number one, for a start, let us have an example of a map. Let me have a simple map. Matter of fact, I can have several. Let me have like three maps so that I can demonstrate using different maps. We want to use a boundary, not an office this time round. A boundary to know who is in charge of the administration and also to know that area is likely to be a what. Let us have a boundary there. It doesn't have to be one line of a boundary. It can be like this one, for instance. A boundary can be dividing that area into several subsections. It can be, these are examples of boundaries in an area. And it can be dividing an area into very many sections. Now, this is a boundary, this is another boundary, this is another boundary. This one is dividing this area into 1, 2, 3, 4 sections. 1, 2, 3 sections. 1, 2 sections. These are boundaries. What will you do with the boundary to get to know the administrator? First thing first, go to the key. Remember, each map has a key. Go to the key and identify which type of boundary is this one. For instance, this one is a sublocation. According to the key, this one is a sublocation boundary. Sublocation boundary. According to the key of this map, this is a sublocation boundary. What's the meaning of that? That means that this is a sublocation 1, this is sublocation 2. Because these are it is dividing. The location is a sublocation boundary. So this is a sublocation, this is another sublocation. And if this is a sublocation and this one is a sublocation, then sublocation plus a sublocation, we have a location. So the area is a location. And a location is headed by a chief. Using boundary is very, very simple. Let's go maybe to the second boundary, and you go to the key. The key of this map again, maybe this one, it is a divisional boundary. Is a divisional boundary. According to the key of this map, this is a divisional boundary. Where did you get the name divisional boundary? From the key. So this is probably division 1, division 2, division 3. Many division makes a sub-county. So this area will be a sub-county headed by a sub-county commissioner. Headed by a sub-county commissioner. Very, very simple. Very, very simple using the boundary. Using the boundary, that this one will be a sub-county commissioner or a deputy county commissioner. I have another example for you here. You go to the key and what you find is this kind of boundary. And this boundary is written sub-county boundary. According to the key of this particular map, this boundary is sub-county boundary. Sub-county boundary. The key of this particular map tells you that this is a sub-county boundary. So this one will be sub-county 1, sub-county 2, sub-county 3, sub-county 4. Many sub-counties make a county. So the whole of this area will be a county. And who is the head of a county? A county commissioner. A county commissioner in charge of the security. In charge of the security in that area. Now, that is exactly what you are supposed to know about administration. It's very, very simple. First of all, the hierarchy of administration. All the way from the village to the county. And the administrators. And I've explained, administrators, they represent the national government in those specific areas. And that is why in our administration, there is nowhere we have written the governor. These are national government administrators, and we have pointed out what they are supposed to do. And we have said that if you want to know who is an administrator of a certain area, or better still, if you want to know which area it is, there are two clues that you are supposed to use. Number one, offices. Or number two, boundaries. And we have gone through the office and we have said, if there is a single office, it is simple. If it is a chief camp and it is only one of them, then the area is a location and the administrator is a chief. What if there are two chiefs camp and no other office? Then Simple mathematics. Very, very simple mathematics. A chief camp plus another chief camp. That means there are two chiefs, and two chiefs will not be the head of a location. Now we have a division, and a division is under district officer or assistant county commissioner. What if there are more than one office that are not the same? Simple. Go for the highest office according to the hierarchy. If there is an office of, there is a sublocation office, there's a location office, there's a division office, or probably there is also another sub-county office, you go for the highest. You go for the highest. And when we are using the boundary, we have said the main point is, first of all, identifying which boundary it is. Where will you get that interpretation from? From the key. So we have said, for instance, example number 1, this was a sublocation boundary, meaning this one is sublocation 1, sublocation 2. Many sublocations will make a location, and a location is headed by a chief. In the second example, I've given that this boundary is a divisional boundary, meaning this division 1, probably division 2, division 3. Many divisions will go to a sub-county. So this area is a sub-county under sub-county commissioner. And I've said he doesn't have to be a sub-county commissioner. Sometimes he will be a deputy county commissioner. And lastly, we have said maybe this one is a sub-county boundary, dividing this area into 4 sub-counties. Sub-county 1, sub-county 2, sub-county 3, sub-county 4. Many sub-counties, according to our hierarchy, we go to a county. So this area is a county, and a county is under county commissioner, in charge of security in that area, in representing the national government, representing the president. And that is that for administration. Maybe for your personal work, for your revision exercise, can have something for you. And please remember to submit your work into this platform. Your assignment, let me give you a simple assignment so that you can use the knowledge that we have. An assignment, the assignment that maybe, let's have a map. Let us have 2 map. Let us have 2 map. Let's have 2 map, so that at least one for the boundary, one for the office, one for the boundary, one for the office. And our boundary looks something like that. And our offices here, we can use a chief camp there and a sub-county office there. Chief's camp, sub-county office there. And your simple question will be, here, let me use red. Question 1. This area is likely to be a what? Which kind of an area is this one? Is it a village? Is it a county? Is it a division? Question 2 here. Question 2 here And question 2 is who is the senior? Who is the senior administrator of the above area? Of the above area. Who is the senior administrator? But here about the second one, I have to mention maybe this one is a locational boundary. Is a locational boundary. Is a locational boundary. I have to give you, now that there is no key, I have to mention which type of a boundary it is so that you can be able to make your judgment correctly. So these two examples are enough to give you an oversight of what we have gone through. Question number 1, this area is likely to be a what? You have the offices. Chief's Camp's office, sub-county offices. So with the knowledge we have learned, you can be able to get that one at ease. Number 2, using a boundary now. Who is the senior administrator of the above area? Who is in charge of administration in this area? Perhaps I would have said this is area A, area B. And with that, our lesson is over. Please submit this one in our platform. God bless you. See you in our next session. Adios.
Welcome to Manifested Publishers.
Hello, my lovely learners. This is Manifested e-learning platform, and I am Teacher Purity. We are going to learn hygiene and nutrition activities for grade 1. So we are starting on a new topic, personal hygiene, and under personal hygiene, we are going to learn about the use of toilets, latrines, and urinals. So welcome to the lesson and hope that you are going to enjoy. Now the use of toilets, latrines, and urinals. What are toilets? What are latrines? And what are urinals? Now toilets, latrines, and urinals are the places where we go to relieve ourselves from our long calls and short calls. So toilets, latrines, and urinals are places we go for our short calls and long calls. So toilets, latrines, and urinals are the places we go for our short calls and long calls. When you are pressed with long calls or short calls, you'll visit a toilet, latrine, or a urinal. Let's start with the toilet. So what is a toilet? Now a toilet is a place where we go to relieve ourselves from our long calls and short calls. And toilets are found inside the house. So toilets are found inside the house, and most toilets have a large round bowl. So take a look of a picture of a toilet. Look at it very well. That's a toilet. And we flush toilets after use. So now after you've used the toilets, you are going to flush it. What is to flush? To flush is pouring a lot of water after you have used the toilet. We flush toilets after use. Then we have latrines. Now latrines are found outside the house. So latrines are found outside the house. So latrines are found outside the house, and a latrine is an open pit where you go and relieve yourself from your long call and short call, and they are always found outside the house. They are built outside the house. Now latrines have an open pit. Now latrines have an open pit. We have said that we flush toilets after use. What about latrines? After you've used your latrine, what are you supposed to do? Now, after using a latrine, you cover it. We cover latrines after using them. So we cover latrines. We cover latrines after use. So we cover latrines after use. You cover the part that it has an open pit after you have attended your short call or your long call. So on your screen there's a picture of a latrine. Make sure that you are observing it so that you can know the difference between a toilet and a latrine. And lastly, we have urinals. What is a urinal? Now, a urinal is a place where boys and men go and pass their urine. So, urinals are places where boys and men pass urine. So urinals are places where boys and men pass urine. It is strictly for boys and men, and they are only supposed to pass urine in the urinals. You cannot go for long calls in a urinal. You only go for short calls in a urinal, and boys alone and men are the ones who use urinals. Girls can use a toilet or a latrine. So this is how we are supposed to use toilets, latrines, and urinals. First, toilets are found inside the house, and we flush toilets after use. I said flushing is pouring water after you relieved yourself from your short call or your long call. Remember, if you do not flush a toilet, it will have a bad smell. Then, latrines are found outside the house. Latrines are always built outside the house, and they have an open pit. After using a latrine, you are also supposed to cover it after use. You cover the pit to avoid the bad smell which can come from the latrine. And lastly, we have urinals, which are used by boys and men to pass urine alone. So if you are a boy, make sure that if you visit a urinal, don't pass your long calls in the urinal. That is a very, very bad habit. Pass urine alone in a urinal. Girls, use a toilet or a latrine. So that's all for this lesson. I'm going to give you some questions. You will answer them and meet you next time. So this is the assignment. The instruction, fill in the gaps with the correct answer. You are going to choose the correct answer from what you have in the brackets and fill in the dashes from question 1 up to question 4. So number 1 reads, boys and men should use a dash to pass urine. The answers in brackets are latrine, urinal. So you select the correct answer and fill in the blank space. Question 2, we dash a modern toilet after use. Clean, wash or flush. So choose the correct answer. The third question, dash are found outside the house. Latrines, toilets. You write for me the answer. And lastly, it is a dash habit to use a toilet. Bad, good. Select the correct answer and fill in the blank space. So thank you for being good listeners. Hope to see you next time.
Enroll your child for the manifested e-learning platform and see their grades grow tremendously. These videos can be downloaded to a laptop for offline viewing or viewed from a smartphone in a cost-friendly format.
Hello learners, welcome to Manifested e-learning platform. The subject is science. We will continue with the topic environment. Welcome to the lesson. The subject is science, standard 8, the unit environment. The unit is environment. We will proceed from where we stopped in our last lesson. Learners, under this topic, environment, so far we have defined soil pollution. We learned about the harmful substances that can pollute the soil. In our last lesson, we discussed the effects of soil pollution on plants and also the effects of soil pollution on animals. That's what we have covered so far under the topic environment. In our today's lesson, we will define the term soil conservation. We are going to define soil conservation. We also highlight the different methods that can be used to conserve the soil. So learners, the subtopic here is soil conservation. Soil conservation. We will start by defining soil conservation. Then we will list some of the methods that can be used to conserve soil. Now, learners, soil conservation is the act of protecting soil from pollution. Soil conservation is the act of protecting the soil from pollution. And learners, you will recall that pollution is the introduction of harmful substances into an object. For example, soil. When we say soil pollution, we mean the introduction of harmful substances into the soil. So, learners, soil conservation then, we are defining it as the act of protecting the soil from pollution, or we can say, or destruction by natural or or human activities, or destruction by natural or human activities. So soil pollution can occur due to destruction by natural or human activities. There are certain activities that human beings engage in that pollute the soil. So soil conservation is the act of protecting the soil from destruction by natural or human activities, or it may be defined as the act of protecting the soil from pollution. So learners, soil conservation is the act of protecting soil from pollution or destruction by natural or supernatural activities, and it involves proper use and care and protection of soil so that it can continue being productive and also useful to plants and animals. Learners, in Standard 7, we learned the usefulness of soil to the environment. We learned how soil is useful to plants, how soil is useful to animals. So learners, soil conservation involves proper use, care and protection of soil. It involves proper use. Let me write that point down. It's an important point. It involves proper use, care and protection of the soil. It involves proper use, care and protection of soil so that it can continue being productive and useful to plants and animals. Soil is very important to plants and animals because one of the reasons why soil is important to plants is that the soil supports plant growth. Soil contains the food that plants require for growth, and these plants are used by animals for food. So if there is no soil, or if soil is not properly taken care of and protected, then that will affect human life, that will affect the life of animals, it will also affect the life of plants. So soil conservation can be done, learners, by maintaining soil fertility. Right? Soil has to be fertile. That means soil has to contain the necessary nutrients that will support plant growth. So soil conservation can be done by maintaining soil fertility, by reducing or eliminating soil pollution. Soil pollution, that is introduction of harmful products, substances to the soil, and also preventing soil erosion. So learners, soil conservation, I'm repeating, can be done through maintaining soil fertility, soil conservation, can be done by maintaining soil fertility. Learners, I hope as I'm writing, you also make sure you write. Okay? Then reducing, we're saying here, soil conservation can be done by 1, maintaining soil fertility, reducing or eliminating soil pollution, reducing or eliminating soil pollution, or avoiding or preventing soil erosion, and preventing soil erosion. Preventing soil erosion, because soil erosion causes the soil to lose its fertility. So soil conservation can be done by maintaining soil fertility, reducing or eliminating soil pollution, or preventing soil erosion. In standard 7 again, we learned ways in which soil can be polluted. We learned ways in which soil can be polluted. So now, what methods can we use in order to conserve soil? Soil conservation methods. Soil conservation methods. Let's discuss soil conservation methods. Soil conservation methods. What are these methods that we can use in order to conserve the soil? Now, learners, there are different methods which can be used to conserve soil. There are different methods that can be used to conserve soil. There are different methods that can be used to conserve soil. So learners, I'm going to list these methods down. I'm going to list them down first, then we'll discuss the methods one by one. Number 1 is avoiding excessive use of fertilizers. Avoiding excessive use of fertilizers. Insecticides, pesticides, and so on. Avoid excessive use of fertilizers, insecticides, pesticides, herbicides. You can add herbicides, etc. Avoid excessive use of fertilizers, insecticides, pesticides, herbicides, and so on. Number 2, or B, avoid dumping of waste on soil. Avoid dumping of waste on soil. That is the second method. Number 3, avoid burning. Avoid burning vegetation cover. vegetation, avoid burning vegetation cover. D, mulching. E, planting cover crops. Planting cover crops. F, making terraces. F, G, contour farming. H, planting trees. Planting trees. Then we have HI, learners. We've said we are listing soil conservation methods. First one is avoid excessive use of fertilizers, insecticides, pesticides, herbicides, etc. B, we've said avoid dumping of waste on soil. C, avoid burning vegetable cover. D, mulching. E, planting cover crops. F, making terraces. Okay. G, contour farming. H, planting trees. I, constructing gabions. Construction of gabions. Then we have controlled grazing. Controlled grazing. So this is controlled grazing. So these are some of the methods that we can use to conserve the soil. So how many methods are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, controlled grazing learners can also be known as proper stocking. Let's write or proper stocking. Goes hand in hand with proper stocking. So learners, we are going to discuss each and every method one by one. In this lesson, we will learn about avoiding excessive use of fertilizers, insecticides, pesticides, herbicides, and so on. So let's explain. I'm going to explain the first method, which is avoiding excessive use of fertilizers, insecticides, pesticides. We also have herbicides etc. Now, learners, fertilizers, pesticides, and herbicides contain chemicals which cause soil pollution when the substances are applied in excess. We are talking of excessive. When insecticides, when herbicides, when fertilizers are applied in excess, that can cause soil pollution. Why? Because these fertilizers, pesticides, and herbicides contain chemicals which can cause soil pollution, and that happens when they are used in excess. So learners, we should therefore avoid excessive use of these chemicals, and we should strictly follow instructions when using them, because instructions are always given by manufacturers on how to use these chemicals. Another way to avoid excessive use of these chemicals is to use manure instead of chemical fertilizers in order to improve soil fertility. So where possible, learners, farmers should also use biological methods of pest control and insect control, instead of using pesticides, instead of using herbicides and other chemicals that contain poison that may pollute the soil. Is that clear, learners? That is the first method, avoiding excessive use of fertilizers, insecticides, pesticides, herbicides, and so on. Because you have said these fertilizers and chemicals and pesticides, they contain chemicals which cause soil pollution. And that happens when these chemicals are applied in excess. So instructions should be followed on how these chemicals are applied on the soil. And we've said that farmers should instead use manure, and where possible they should use biological methods in controlling pests, controlling insects. So learners, that will mark the end of our today's lesson. In our subsequent lessons, we are going to discuss in detail the other methods of conserving the soil, that is avoiding dumping of waste on soil, because this dumping of waste on soil can be done by industries and factories. They can also be done by people, okay, domestically. So we will be discussing all these other methods in our following lessons. Today we will stop at that, but just to recap what we've done in our today's lesson, learners, we introduced soil conservation, whereby we also defined soil conservation as the act of protecting the soil from pollution or destruction by natural or human activities. We've said that soil conservation involves proper use, care, and protection of soil. And soil pollution, we said, also can be done by maintaining soil fertility, reducing or eliminating soil pollution, or preventing soil erosion. Then we have listed the various methods or different methods that can be used to conserve soil. One is avoiding excessive use of fertilizers, insecticides, pesticides, herbicides, and so on. B, avoid dumping of waste on soil. C, avoid burning vegetation cover. D, mulching. E, planting cover crops. F, making terraces. G, control farming. H, planting trees, I, construction of gabions, then lastly, controlled grazing or proper stocking. So learners, before we stop the lesson, I'm going to give you assignment. This is your assignment. Question 1, what is soil conservation? Question 2, list 5 methods that can be used to conserve soil erosion. Go through the video once more, then close your exercise books and then do the assignment. Thank you for your attention and God bless you.
Enroll your child for the manifested e-learning platform and see their grades grow tremendously. These videos can be downloaded to a laptop for offline viewing or viewed from a smartphone in a cost-friendly format.
Hello learners, today we are going to continue with our topic, angle properties of a circle. In the last lesson, I had given you an exercise from the learner's book, exercise 19.1, question 4 and 5. And I hope you had done the questions. So I'm going to write the questions on the board, and before I write them, I'll read question 4, which I'm going to start with. I read question 4. In the figure below, O is the center of the circle. Show that the reflex angle POR is twice angle PQR. So I write the question on the board, then I will solve it. So that is the question. In the figure below, O is the center of the circle. Show that the reflex angle POR is twice angle PQR. So before we go to the solving of the questions, we have to get the underlining concepts before we get the angles. So one of the things we'll do, we'll introduce a chord running from Q right through O to the other edge of the circle. It will actually just be like the diameter. So where it touches the circle, I can give it a point D. That is point D. After getting that, you'll find when I have that chord QD, QOD or QD, I can I'll introduce another line there, DR, and also introduce another line there, which I'll call it PD. So before we continue, there are concepts there you should get. In the previous lesson, you learned that if the diameter is a chord, it forms a right angle, it subtends a right angle in each of the segments. So if I come on the board, I'll use chord QD, which is actually what? Chord QD is the diameter. So this angle, it is subtending, isn't it? There is an angle, it subtends here. The whole of that angle, isn't it? Angle QRD is a right angle because it is subtended by a chord QD, which is the diameter. But now, meanwhile, I'm interested in angle DRO because it is going to help me to get the reflex angle. So the first thing, I'll get angle DRO, angle DRO. What is it? Because I've already told you that the angle subtended by the chord QD, the angle subtended by the chord QD, which is QRD, is equal to 90 degrees. So to get DRO, it will be equal to 90 minus y. So I'll actually write here 90 minus y degrees. That is angle DRO. I'll also come and get angle DPO. The same thing happens. Since this one is the diameter, it subtends a right angle here. It will subtend a right angle. Similarly, angle DPO will be equal to what? It will be equal to 90 minus x. I'll get that angle, isn't it? It is 90 minus x. It is right here, this angle. Minus x. So I've now got one of the angles, and if you look well, this is the radius, this is the radius. So this is an triangle POD. Triangle POD is isosceles, and triangle DOR is isosceles. So a pair of the angles is equal. So this angle is equal to that angle. So having got that, I have to prove by getting the actual value of the reflex angle. I'll go straight to getting the reflex angle POR. So the reflex angle they are asking for, POR, it is this angle, POR. For many who do not know, a reflex angle is greater than 180, but less than what? 360 degrees. So let's go straight to getting our reflex angle, POR. If you look well at the diagram, angle POR, that reflex angle, is the sum of two values of angles POD and DOR. Isn't it? From the diagram, you look, if I have POD and I add to ROD, I'll get the value of the reflex angle. So reflex angle POR is equal to the value of angle POD plus the value of angle DOR. So if you get the value of the two angles, you'll get the value of that reflex angle. So we go back to what I told you about an isosceles triangle. Two pairs, a pair of the angles, two angles are equal in isosceles triangle. So if I have here 90, this is an isosceles triangle. Are we together? So this value is the same as that value. So if I want to get POD, isn't it? If I want to get POD, I'll take the sum of the angles in a triangle, which is 180, subtract the value or the sum of the two values of the isosceles triangle. So I'll start with POD, isn't it? I'll start with this one, POD. POD is equal to the sum of angles in a triangle is 180 degrees. So I'll take that sum, 180 degrees,